This is topic 8.4, 8.5, 8.6 for AP Environmental Science. Make sure you pay attention. Up here is our learning target or our learning goal, and it will help you fill in your study guide. So the first thing you need to understand is how we divert water. Some of this you learned in a previous unit, but let's go through some things. Levees are probably new. You haven't learned that in a previous unit. But so water pollution primarily occurs through alteration of water and waterways. We do something to it. So most rivers typically overflow their banks during certain periods, leading to nutrient-rich water reaching floodplains. So this is why farming is really, really good near rivers, is because periodically rivers flooded and brought with it nutrients in the sediments, nitrogen, phosphorus, potassium, other micronutrients as well. Well, flooding also causes damage, and humans don't really like to spend thousands or millions of dollars to repair flood damage, so we do things to stop it. One of the things that we do is a levee, and you can see the picture here of what a levee is. Now, I live in a community where we have some levees that protect my community from the river, which is adjacent. Kind of similar to this, but the difference is that the floodplain was still left really, really wide for that river, and the levees only protect in massive rainstorms like an El Nino storm or a tropical storm, which is very rare where I live. The tropical storms, at least. El Ninos happen. El Nino rainstorms. We have an El Nino every 3 to 7 years, which brings massive rainstorms during the winter. Okay, so what's the problem with levees? It decreases land fertility because it doesn't allow those nutrients to recharge the soils with our nutrients. Sediments are carried further out than normal. So normally we would have sediment depositing at certain places in the river that create habitat for species, sandbars, sometimes we call them. Flooding is forced to occur in different areas than it was historically. This type of thing that we are doing as humans, ancient worlds also built levees, but on a huge scale, it's not that new. Maybe the past 150 years, maybe a little bit earlier than that. But we used to, in most places, kind of let the rivers flood a little bit, and then we wanted to stop that. So we built levees. Okay, so in other words, the flooding that used to happen no longer happens in the same way. All right, so a dike is a very similar thing to a levee. You just need to know for the AP test, dikes and levees help keep water back from flooding. Okay, dams is something you probably learned with hydroelectric power in Unit 6. And so we know what dams are, and then the back of a dam is a reservoir that holds the water. It's usually a lake of some kind, often a lake, not always. And so the good parts of dams are that they provide recreation, electricity generation, an abundant water source that we can use for agriculture, like crop irrigation, we can use for drinking water. So we save the water instead of letting it flow all the way to the ocean. So those are the good parts. That's why we build dams, and we all rely on dams every day for many things. Well, many parts of the world do, not everywhere. Okay, so the problems with dams is downriver experiences water loss, so you are limiting the amount of water that goes downriver. Upriver, you have more flooding, and then of course it influences the fish species, and that was spelled wrong, not by me, so I'm going to get rid of that and spell it correctly. And so fish species may not be able to get across the dams without the help of fish ladders. And we learned that back in Unit 6. All right, let's talk about an aqueduct. Right next to the school I teach at Saugus High is a pipe. That is the Los Angeles Aqueduct. I am not in Los Angeles, so this water goes through my city to the city of Los Angeles. It was built just over 100 years ago by a guy named William Mulholland. There's a whole story with that. But that is a pipe, and it carries water to the city of Los Angeles, takes it from Central California out in the deserts on the eastern side of the Sierra Nevada mountains, and sends it to Los Angeles. Where my city gets half its drinking water from, well, half is groundwater, and the other half is the California aqueduct that takes water from Northern California and sends it all the way to Southern California. They're historical. Ancient Greece, ancient Romans had aqueducts. It's been used a long time. These big, huge engineering projects are, of course, new in the past 100, 150 years. And then sometimes these aqueducts can have really devastating consequences. For example, here's the Aral Sea in Kazakhstan and Uzbekistan in southern Eastern Europe. And you can see that water diversion through aqueducts really shrunk the size of the sea. In California, let me go back up a slide. This aqueduct here, the Los Angeles aqueduct that runs in this pipe, actually did not allow Mono Lake to fill. And so that's been a problem for about 100 years. Okay, some other ways that we manipulate water is that in some places in the world we have desalination or desalinization, same thing, plants. So basically you're turning salt water into fresh water. It can be done in two ways, distillation and reverse osmosis. And so you have these a lot in the Middle East, you have them in Israel. We do not have them so far in Southern California and California, even though we experience massive droughts, because they're very expensive and the amount of energy it takes. So it's going to take super huge amounts of energy, which are probably going to have to come from burning fossil fuels to do this process. So it is much better, not just environmentally, but cost-wise, to conserve water and then to keep the water when we do have big El Nino years where we do get lots of rain. And so that's more cost-effective and ecologically friendly than building desalination plants, even though that is expensive to build new reservoirs to save all those rains. Okay, so you can see the amount of renewable water per capita. Remember, per capita means per person, and you can see that in some places they have much less water per person than other places. Some places have a lot of water, like Canada has just tons and tons of water because they don't have a huge population. They have a good-sized population, but they also get massive amounts of rain in those biomes. The United States is actually pretty good. We do have areas of drought. California gets drought, Texas gets drought. We do get areas of drought, but overall we have a pretty good amount of water per person. But you can see other places do not. All right, let's talk about wetlands again. So remember that wetlands are categorized by standing water or water saturated soil that's there for part of the year or all the time. You want to remember ecosystem benefits here. They're important ecosystems. For humans, they purify water and remove pollutants and excess nutrients. They absorb floodwaters and buffer shores from damaging storms. Mangroves are a type of wetlands in subtropical and tropical locations. They have these big roots that hold shoreline soil. They can provide nurseries for open ocean fish. All wetlands are major carbon sinks, know that. All right, so this is a review of a lot that you learned in Unit 1 with our aquatic biomes. Ecosystem services is what you learned in Unit 2. And so these are all the things that provide, actually some of these are wrong. So let me actually adapt this. So we have ecological for nature, and ecosystem services. Ecological benefits are for nature, and ecosystem services are for humans. And so on this list, you can see that some of these things are for nature, like habitat and biodiversity are considered ecological benefits. Recreation would be an ecosystem service. And so some of these, again, looks like most of them are ecosystem services. Looks like habitat and biodiversity is really an ecological benefit, not for humans directly. All right, so what do we do to wetlands? We drain them. Like this is a drained wetland, and it might be turned into houses, or it might be turned into agriculture. In the United States, we drain them to get rid of mosquitoes. Back in the day when we used to have malaria in the US, this was a long time ago, 1700s. And the current area of wetlands is about half of the wetlands that were in the 1600s. Okay, a reminder of eutrophication. We learned it before in Unit 1 when we studied the nitrogen cycle and the phosphorus cycle. Here it is again. So remember, nutrients from human activities end up in bodies of water, causing nutrient pollution and altering food webs and water. Sometimes it is called cultural eutrophication. It's the same thing for our purposes. I just don't want you to be confused on a test question that might say cultural eutrophication. The opposite is oligotrophic. They have low nutrients. They're like crystal clear water, which is pretty to look at, but doesn't have a whole lot of nature in it. Okay, so you see the picture, oligotrophic, eutrophic. All right, so here's what happens with eutrophication. Write this down on your study guide. High nutrients, nitrogen and phosphorus primarily. So you should write N and P. So we're writing here N and P, so you don't forget nitrogen and phosphorus. Cause an algal bloom. That's a P, not a D. Here we go. All right, then the algae die because eventually they run out of nutrients or they block the light or something and it dies. Then the microbes like bacteria digest the dead algae. The microbes use the oxygen, which creates a hypoxic or an anoxic environment, which kills the fish. They need dissolved oxygen to live. All right, so what are the sources of nitrates? Fertilizer runoff, animal manure runoff, sewage spills. Those are the three. You got to know the three. Fertilizers, animals, manure, animal poop, and untreated human sewage. What are the sources of phosphates? The same as above, but you can add detergents to that. So a lot of our detergents have phosphorus, although there have been laws like California no longer allows phosphorus in detergent for this reason. What are the ways farmers can prevent nutrient runoff? How would they reduce synthetic fertilizer use? Okay, so this is often on an FRQ. How do you reduce eutrophication? A lot of times students will say, well, stop using fertilizer or reduce fertilizer. That's not good enough. You need to explain how. How would a farmer, because remember, we got to use fertilizer. We won't grow enough food for our people, for our population, unless we use fertilizer. So we can't just stop using fertilizer. We'll all starve. That might be hyperbolic, but a little close. So here's your answers. You got to know these things. Planting buffer zones with plants and shrubs that absorb excess fertilizer. So between the field and a body of water, you can plant some extra plants and shrubs that are really good at absorbing nutrients. Spray your fertilizer to avoid rain. So if it's going to rain, don't put fertilizer on. You can even do that at home. Don't fertilize your lawn when it's going to rain. Use drip irrigation so you have less water runoff. To reduce fertilizer use, plant crops that do not need as much fertilizer in general. Plant legumes instead with crop rotation, because remember, legumes add nitrogen through nitrogen fixation. Okay, let's talk about CAFOs, feedlots. How do they increase eutrophication? So here's a picture of one right here. So much poop, they stand on poop. We pass by these sometimes driving north on the 5 freeway or Interstate 5, and sometimes there's just so much poop that the cows are just standing on the poop, the cattle standing on the poop. What are some ways we can fix eutrophication after it occurs? We can do mechanical mixing of water with some machines that will mix it to try and add oxygen, because remember, moving water adds oxygen. Herbicides to kill algal blooms and prevent nutrients from entering water. What's asphyxiation? That's another thing for the lack of oxygen. We studied that last unit with carbon monoxide as an asphyxiant. Big thing. Make sure you know that algal blooms do not decrease dissolved oxygen because they're photosynthesizers and they add dissolved oxygen. What happens is the algal bloom eventually dies off as the nutrients deplete and become a limiting factor. The decomposing bacteria use the dissolved oxygen, so don't forget that step. Otherwise, it's illogical. Here's our dead zones around the world. You can see they're around coasts, mostly because of nutrient runoff. Here's the oxygen sag curve. In the last video, we went through this. Here's another picture. You can see that the sewage pipe enters here with raw sewage, and so the oxygen goes down as it's being used by the decomposers. Sediments deposits, we talked about in the last video, but here it is again. They can block light, so your aquatic plants can't photosynthesize. Predators might not be able to see prey. Organisms can be buried. So that's a little review. And then here, thermal pollution. We talked a little bit about that in the last video and on the chart you made. Here's some review. Thermal pollution is when the water is too hot. Sometimes you can have species that die immediately from thermal shock. And also, warmer water does not hold as much dissolved oxygen as colder water, which can lead to hypoxic or anoxic water. Okay, how do flower plants cause thermal pollution? We learned this in Unit 6 when we did diagrams of the power plants. So here's a review. Water that is boiled and steam used to spin turbines is sent to cooling ponds. These ponds can sometimes be discharged into bodies of water, which can cause thermal pollution. How does deforestation cause thermal pollution? The removal of trees near rivers or lakes or ponds causes more sun and less shade on the water. How do hydroelectric dams cause thermal pollution? When water is held behind the dam instead of being allowed to flow downstream. This large area of water can heat up more than if it had been a river. Okay, let's relate this to noise pollution, which was a part of Unit 7. So how does this affect organisms in water? In water, ships and machinery noises interfere with animal communication through echolocation. You have your whales, your dolphins, your sea turtles, and ships can be designed to minimize these noises. New ships are being created which have quieter engines and machines. And you have southern resident killer whales find their food. You can read the little diagram. Cartoon. That is it for this section.